All right, so number one, we have to come up with 3 points. We're going to plug them in for an exponent. So nice numbers to plug in for an exponent are -1, 0, and 1 for x values. When I plug in -1, 3 to the -1, that's just the reciprocal of 3, or 1/3. When I plug in 0, 3 to the 0 is just equal to 1. When I plug in 1, 3 to the 1 is 3. Now you may have different order pairs than these, and especially the fractions. Some of you may have something different than the -1, 1/3. That's okay. We can have 2, 9. It just gets a little more difficult to get that on your graph, but there are other order pairs. There's an infinite number of them that you can graph. So go ahead and plot your points. -1, 1/3 is about here. 0, 1, and then 1, 3. The domain is all real numbers on every exponential. The range, well, we have a horizontal asymptote. It doesn't ask us this, but I've been doing it, so I would kind of like to see this. So I very well may ask it on the test. What is the horizontal asymptote? Well, it's the line x equals, and it's whatever your k is, which is 0. There was no k there. So our range is everything above that. You can see we're graphing above the 0, because x equals 0 is the horizontal line right here at the x-axis. Or sorry, it should have been y equals 0, my bad. Y equals 0, not x equals 0. And so we're graphing above that. So our range is y is greater than 0. And so connect the points. So on the left side, it's traveling next to or along with the asymptote. On the right side, it's traveling up. Number 2, here you may, because of the h value in there, you might very well want to use your graphing calculator for this, which is perfectly fine. So let me pull that out so I can demonstrate that. So if you want to type in 3 to the power of x plus 2 plus 1, and I'm going to go to the table, which is in blue, so I can find some nice order pairs. Those are all big numbers, probably bigger than I want to graph, so I'm going to scroll up further. There's some numbers that are more reasonable. If I want to graph 3 of them, I don't really want the 10, so I'm going to go with -3, and that's 1 1/3, or I could call it 4/3 just because I don't have a lot of room to write in that order pair, so I wrote it as 4/3. Then I have -2, 2, and then I have -1, 4. So -3, 1, 2, 3, and then 1 and 1/3. That's what that was. And then -2, 2, -1, 4. Now, my domain is all real numbers again. My range is going up. This time it's not y is greater than 0 because I have a k value. My k value is a +1. So it's y is greater than 1. Here at 1, I can put a dashed line because I have a horizontal asymptote at y equals 1. So connect the points. Make sure you don't cross the asymptote. And there's my graph. Next one, I don't have an h value. I don't have to do anything to my exponent, so I'm going to use a -1 as 0 and a 1 again. 1/4 to the -1 is 4. Anything to the 0 power equals 1, and 1/4 to the 1 is just 1/4. So -1, 4, 0, 1, 1 and 1/4. Domain, it's always all real numbers. My k value here is 0, so y is greater than 0 is my range. My horizontal asymptote is the line y equals 0. So that's the x-axis here. And so there we go. Number 4, this time I've got an h value in there, so I may use my graphing calculator again. I already know the domain's going to be all reals. Range is going to be y is greater than my k. My k value is this +3. And so my horizontal asymptote is going to be y equals 3. Okay, so I'll go ahead and graph this. So 3/5. I can go ahead and put it in parentheses like they had in parentheses. The parentheses aren't actually, yeah, they probably are necessary there. That was incorrect. I do need the parentheses. Parentheses 3/5, exponent x plus 4, arrow to the right to get out of the exponent, plus 3. I'm going to go to my table, scroll up. So I've got one nice number here, -4, 4. The one above it I'm going to use as well. It gives me 4.67. I know that's 4 2/3. I'm just going to squeeze it in the 2/3, 4 2/3. And then -4, 4 was a nice one. The one below that, -3, 3.6, not so bad. I don't have a lot of decimals, just one place after the decimal. So 2, 3, 4, 5, 1, 2, 3, 4 2/3, about there. -4, 4, -3, 3.6. Oh, sorry, went too far. So let's go ahead and connect those dots. All right, now we go to solve the equation. I notice 64 can be written as a power of 8, so that way I can have the same base number, which is what I need. So I'm going to write 64 as 8 squared. I didn't change its value, I just wrote it, so it's the same base number. As soon as I have the same base numbers, I know the exponents have to equal. 4x plus 2 has to be equal to 2. I got to ignore my base numbers. Solve this, I get to subtract 2 from both sides, so I get 4x equals 0. Then divide by 4. 0 divided by 4 is 0, so I get x equals 0. On the next problem, looks like they're both powers of 4, perhaps. You may have to check and see if 256 is in fact a power of 4. But it's 4 to the 4th. It is a power of 4. You can just start trying on your calculator. You can do 4 to the 2nd, 4 to the 3rd, 4 to the 4th, etc. until you find it. So here, 4 to the 4th, it already had an exponent, so I have to distribute that exponent. So it becomes 4 to the 4b plus 8. Now I have the same base numbers, so I can drop the base numbers. I know the exponents have to equal. So 4b plus 8 has to equal 2 minus 2b. So let's add 2b to both sides. Subtract 8. Divide by 6, I see b is equal to -1. Number 7, we're depositing money. It is compounded, and it's compounded monthly. There are 12 months in a year, so my n value is 12. We use our formula. The principal 1 plus the rate divided by n. It's the exponent of n times t. So I'm initially depositing $700, so that's my principal. 1 plus the rate was 4.3%. You have to change it to a decimal, so you have to move the decimal 2 places to the left, so add in that 0. Divided by n, there's 12 months in a year, so we're getting the 12th of that, interest every year. Close the parentheses, the exponent, take that same n value, 12, times the number of years. We're going for 7 years. So now if I type this in, I'll see what my balance is. So, pull out the graphing calculator. So I'm going to have 700. Let's see, 1 plus 0.043 divided by 12. Close the parentheses, raised to the exponent of 12 times 7. Depending on your calculator, you may need to put this in parentheses, or you may need to multiply it ahead of time. 12 times 7 is 84. So to the 84th power, and we get our answer. $945, and then if we round to the nearest penny, that would be 34 cents. Which seems like a reasonable balance. Okay, now we write in exponential form. So the base number was 2, it stays 2. 4 becomes its exponent, and that equals 16. So 2 to the 4th equals 16. The next one, then base number is 9, stays 9, raise it to the power of -2, and that then equals to 1 over 81. So we rewrote those. Let's go to the back page. Now we do the opposite. We have exponential, we want to write it in logarithmic form. So log, the base number happens to be the base of the power, which is 9. Log base 9 of the, now jump to the other side, 1/9. You may put that in parentheses since it's a fraction, you probably don't have to. And then equals, and we've isolated the -1. Number 11, log, base number is the 2 of 256 is equal to the 8. Now evaluate, so we're trying to figure out what exponent to take 3 to get 1/9. Well, if you want to get a 9, you have to square the 3, so its exponent's going to be a 2, but to get it to the denominator, the exponent had to be negative. So 3 to the -2nd power equals 1/9, so -2 is the answer. 8 to what power is 512? Well, honestly, we can pull out the calculator if we're not sure. I already know 8 squared is 64, so that's not going to be it, but we can try it and see. Oh, no, that's 64. Let's try 8 to the 3rd, so we can just start trying things. Oh, we got it. 8 to the 3rd is 512, so the answer is 3. That's what exponent I have to take the 8 to get that. 27 to get 3. Now this one you have to kind of work backwards. I actually know I need to cube root it, so it's going to be a 1/3. If you're not sure what to do, which is quite possible on a problem like this, set it equal to x. And then rewrite it like we did on these previous problems up here, or I guess on the other side, rewrite it as an exponential. So we could say 27 to the x equals 3, and then we can solve like the problems on the other side. We'd say, oh look, they're both powers of 3. 27 is 3 to the 3rd. So we can replace 27 with 3 to the 3rd. 3 is 3 to the 1st. Here there's an exponent raised to an exponent on the left side, so you have to multiply the exponents. 3 times x is 3x. So we have 3 to the power of 3x equals 3 to the 1st. Now the base numbers are the same, so the exponents have to equal each other. 3x has to equal 1, because we just get rid of the base numbers. 3x equals 1, divide by 3, I get 1/3 is my answer. Number 15 and 16. The instructions here don't quite match what we were doing in class, and so I don't particularly care so much for the x-intercept. I would rather do a little more in line with what we were doing in class. So I'm going to ask us to look for the domain in the range, and this one's going to have an asymptote as well, but this time it's going to be a vertical asymptote. So let's go ahead and find those things on both of these problems. And we'll use the graphing calculator to help us on these. So on the first, we'll just type it in right away. So y equals the first one. Let's clear that out. Log base 10. So your log base is under your math. You have to scroll down a ways. There it is, log base. Base of 10. Arrow to the right. And we're just taking the log of x. So you can type in x. We can go to table, second table. See lots of errors. Let me scroll down. That does tell me something about my domain, because x can't be just anything. X has to be greater than, and we know it's got to be at least greater than 0, because 0 didn't work. And that happens to be what the domain is. We look at the h value. The h is what's in the parentheses here. There is no number, so it's a 0. So our h value, on the other side we used our k value, and in the logarithmic problems we use our h value. H value is 0, so domain is x is greater than that. Your range, it got flipped around from the last side, the range is all real numbers. My vertical asymptote, that h value is what I'm going to use, so I'm going to use x equals 0 for my vertical asymptote. So then what are some ordered pairs that do work? Well, 1, 0. Technically that's my x-intercept because it has a 0 for a y value. So you can put it here for your y-intercept. You can list it as one of the other 2 ordered pairs. I don't really care. Let's go for 2 ordered pairs. Let's see if there's any other nice ones. There may not be. Oh, there's one at 10, 1. I don't know if I want to go all the way out to 10, 1, but it's not too bad. I'll probably have to go by 2's on my graph. So let's go ahead and graph it. I'm going to go by 2's. I'm going to put a little 2 here to denote that I'm going by 2's. So, and then I'll be consistent. I'll go by 2's on both of them. I don't like to stretch it too much, so I like to be consistent. So 2, 4, 6, 8, 10, 1. And then 1, 0, only half, over half right there. And my asymptote is y equals 0, or x equals 0. That's the y-axis. So 2 points is a little difficult to understand what's happening. If we put another point, that might help. But if I have my asymptote, that helps me understand. That's why I really like to put the asymptote in there. As I traveled to the left, it went down, and I can't cross the asymptote, so I'm going to have to curve down even further, curve down pretty fast. As I travel to the right, it got, it's kind of flattening out, but it is still rising. So there's my graph for number 15. If I look at the graphing calculator, hit graph on the calculator, we can see it's about right. It kind of stops. It kind of messes up around that horizontal or the vertical asymptote. It just kind of stops the graph, but otherwise we can generally see that that looks accurate. All right, for the next one, I'm going to go ahead and graph this again. So let's clear that out. Let's go to log base again. Log base, this time we have a base of 12. Oh, I forgot. There was a 3 in front of the whole problem. So if you ever want to drop something in front and you've missed it, the INS above your delete, it's in blue, it means insert. So if you want to insert something in without overwriting, you can hit second in that, and then you can type in your 3 now. So there. So now I have 3 log base 12 of x. Now this is confusing because there's parentheses and there's no parentheses in our problem. So don't put plus 2 inside the parentheses. There is no parentheses around the x plus 2. So I need to get out of the parentheses. So it will show parentheses around the x. That's okay. But don't put the whole thing in parentheses. So exit the parentheses and then put plus 2. So this is what it's going to look like in the calculator. So I'll go to my table. And scroll up. There's my error. Looks like it's at 0. Since there's no parentheses, the h value is 0. The h value would have been found in the parentheses. So my vertical asymptote is in fact x equals 0. So my domain is once again x is greater than 0. The range is still going to be all real numbers. It's always all real numbers for logarithms. So now for some ordered pairs, it doesn't even give me the x-intercept. So I'm not even going to bother with the x-intercept in this problem. But it does give me 1, 2. Does it give me any? I don't want to go out too far. I'm not seeing nice numbers. There's a 5. I could go out to 12, 5, but then I have to adjust my scale. Don't necessarily want to do. So I'm just going to give another point. Maybe like 3, comma, and then that decimal is about 3.33, I'm going to call it. It's 3.26, but, or 3.326. I'll call it 3.33. So asymptote, x equals 0. We have a point at 1, 2, and then at 1, 2, 3, 1, 2, 3, and about a third. Okay, so I see it's rising from left to right, so follow that asymptote, curve up, hit those points, continue kind of leveling out. And it gives me that picture. If I could hit my graph, we'll see if it looks about like that. Sure, it looks good. It's zoomed out more than mine, but it seems reasonable. All right, and that's the end of the worksheet. Thanks for watching.